Okay guys, welcome to week 1 for the calculus guide. What you're going to find is the first couple weeks, maybe even the first 3 or 4 weeks, things are going to be really familiar, but these things are important enough that we need to go over them again before you start calculus, and you need to be really solid with this stuff. So the hope is that you'll see enough of it this summer that when you get into class next year, you'll automatically know what to do when you see a given problem. I'm going to start with things that my calculus class messed up on all the time, and that's how I put this program together. Okay, so these are common mistakes, but things that are like you need to know. Okay, so let's start with the page in your note guide, and your binder should be in the first section, and you can just take notes along with me. If you miss something, feel free to rewind or pause so you can write it down, but we're going to start off with the basics today. So all things fractions is sort of what this is titled. So what I'm looking at here is just to make sure you know a couple of things, like cross-reducing. If you see, 3 tenths times 121st, I hope you know now not to actually multiply them, but to cross-reduce. And once you cross-reduce, then it's as easy as multiplying the top times the top and the bottom times the bottom. So that's one thing that I for sure want to make sure you know how to do. Another thing is when you're dealing with a fraction over a fraction, a lot of my students would just sort of freeze, like 1/2 over 3/5. Remember, that's the same thing as 1/2 times 5/3. So multiply by the reciprocal of the denominator and get your answer that way. Okay, and the last thing with fractions that people messed up on would be called what are called compound fractions. A compound fraction, this is technically a compound fraction, but when I think of compound fractions, I think of compound complex fractions, which just means that you have something in the numerator or denominator, and the other part's just a little bit more complicated. So maybe there's like another fraction within the fraction, and I have a lot of people that want to right off the bat, they want to use this trick over here of multiplying by the reciprocal. Not okay. You must first get these two fractions together. So we're going to need a common denominator down here of 14, which makes that a 7, plus makes that a 6. 7 plus 6 is 13. So make sure you do that first, then you can work on the whole flip and multiply thing. Remember to cross reduce to make it easier, and you'll get 21 over 13. So that's the whole fraction thing. And of course in calculus you'll be doing this with sine or cosines. There may be square roots. I mean, there's no telling, but this is the basics of your fraction math. Okay, so the next section I want you to be good at is exponents and radicals. Every year when we do a practice AP question, there'll be a question that looks like this. Actually, you know what? It starts off looking like this. Sorry about that. It'll be like 32 to the 3/5 power or something like that, and my students freeze. Okay, but this is very doable. There was a way that you learned once upon a time where you could think of this as a radical instead of an exponent, and the way you do that is the denominator comes out as the index. Okay, and then whatever the numerator is here, that actually is the power on the problem. And so when you approach this, you just need to take the 5th root of 32, which I believe that's 2, right? 2 times 2 times 2 times 2 times 2 is 32. Then you've handled that, and you'll take it to the 3rd power, and you'll get your answer. Okay, so if you want to write that as a rule, as a conversion rule, it would be something like this. Let's put an A here and a B here, and this is interchangeable, so it would be x to the b over a. So you can go either direction. If I were to give you like the 3rd root of 4 p to the 2nd, okay, then what you would do is you'd be able to write that as 4p to the 2/3 power, and you could write it like that. So either way that's going to help you simplify or solve it is going to be just fine. Okay, if you were asked to actually solve this one, I would probably, well, there's not a third root of 4. I'd probably leave it sort of as is. So, all right, so there's that. Now, factoring. People always need help with factoring, right? There's a couple different kinds of factoring that are going to come up a lot. And that would be just if you were to see like 4x squared minus 25. Okay, a lot of times this type of factoring will come up in calculus. So remember, this is a difference of squares where you can take the square root of both the front term and the back term and factor it this way, right? And one's a plus and one's a minus. That's one kind of factoring. Another kind will just be, you know, good old-fashioned, like, factoring, where you've got a trinomial and you have to break it down. So let me try to make something up here. Something like... okay, something like that. So when you see this kind of factoring, the first thing that you're going to want to do is factor out any common term that you may have. So I'm going to take a 3 out of everybody. And then beyond that, I'm going to try to, oops, that's a 2. I'm going to try to factor this. Now, I know nobody likes it with a leading coefficient, and I don't have a trick here. It's just guess and check. So we know there needs to be 1s back here because of that 1. And we're just trying to multiply them in a way that will create a negative 1 in the middle, and I believe that will do it. Okay, so that was just another type of factoring that you guys need to practice. There's all kinds of factoring. You'll see it on the practice assignment. Okay. Alright, and then the last thing would be composition of functions. Okay, this you've done since Algebra 2. You did it in pre-cal. You will see it again in calculus. This is just the understanding of composing functions. You know, if I tell you that f of x is 3x cubed minus x plus 1, okay? And then I tell you... to do, let's see, maybe I'll give you another one. G of x is x square root of x. Let's do that. Okay, so if I give you these two functions, people are pretty good whenever it's like, when it's just a basic like f of 2. Okay, we know to plug in the 2. Okay, that's pretty dang easy. That's going to be a 24 minus 2 plus 1. And so that part's pretty easy. Even if I said like f of... let's see if I did f of x plus 5, okay? Whatever is in this parenthesis, make sure you understand it's going to get plugged into the function and replace the x that you saw. So instead of 3x to the third, this entire thing is going in for that x. This entire expression is going in for that x, and you would have to like multiply it all out from here. And then if you saw like g of f of x, which could also be written this way. Sometimes I've seen it with that little open circle right there. This is g composed with f, or g of f, however you want to say that. This is just saying that this is going to be plugged into that. Whatever's in the back is going to be plugged into whatever's in the front. So f is going into g, so all of this is going into the spot of that. So my answer for this, g of f of x, would actually be the square root of, and then all of that's going in. Okay, so that is a composition of functions. You can multiply them, you can add them, you can divide them. I mean, you can do everything that you want, and it's really just what you think. So just in case you ever were to see something like that, it just means to add what you can here. Now, none of these are like terms, so I mean, I really would just recopy this plus this one, and since there are no like terms, that is your final answer. If something were to go together, of course you could combine them and put them together. So these are the basics that people are weak at, so please practice these as our first lesson before we get into functions and limits and something called a derivative this year. And after you've tried the practice problems, you can watch the solution video, which will show me working out every problem very quickly, and we can make sure we have the same answers. And we will see you next week.